let's define a procedure that uses some of these list processing procedures in order to find the even subsets within a list. What are those? Well, let's say that a non-empty subset of a list S is a list containing some of the elements of S. It's non-empty. It could contain all the elements of S or just a few of them, but not none of them. And let's say they stay in the same order that they appeared in S. With that definition, we can say what we're after. A procedure that takes in a list S and gives us back the non-empty subsets of that integer list S that have an even sum. So, when I call even subsets on 3, 4, 5, 7, it tells me all of the non-empty subsets, like here's some of the values in 3, 4, 5, 7, 5, 7. But it only shows me the ones that have an even sum. So 5 and 7 sums to 12, 4, 5, 7 sums to 16, but nowhere here do we see 3, 4, which would sum to 7, because 7 is an odd number. So how are we going to define this procedure? Well, here's one approach. The even subsets of S include all the even subsets of the rest of S, as well as the first element of S, followed by an even or odd subset of the rest. What do we mean by even or odd? Well, it depends on the first element of S. If the first element of S is even, then you want an even subset, because if you add two even numbers together, you get an even number. If the first element is odd, you want an odd subset, so that when you add two odds together, you get an even number, and our goal is to find even subsets. There's one more case which doesn't involve the rest of S at all. It turns out that a subset of S that's even is just the first element of S if that's even. Okay, let's try this version out and write some code. The even subsets of S. Well, if it's the case that there are no elements in S, then there are certainly no non-empty subsets. With that base case, we can now append together the three different sources of even subsets that we saw on the previous slide. One was the even subsets of the rest of S. The second was a whole list of subsets where they all start with the first value in S. So what we're going to do is map a procedure which takes some existing subset, let's call it T, and conses on the car of S to T. Now, we said in the slide that what we want to cons it onto is either an even subset or an odd subset, depending on if the car of S is even. When it's even, we need even subsets. When it's odd, we need odd subsets. So that takes care of the second case, except we're going to have to define odd subsets in a minute. The third case was creating a one-element even subset only if the car of S is even. So this last thing we're appending is either going to be nothing if car S is odd, or one thing if it's even. How do I write that? Well, it's just another if. If even car S, then I need to put that one thing into a list. And what is that one thing? A list with one element, the car of S. Now, how do I say append nothing? Well, we're already inside an append, so we could just put nil here to say there's nothing left to append. So that looks great, just as long as I can get the odd subsets, which I'll get by changing all the evens to odds in this code. Except we need to look carefully at what happens when we're consing the car of S onto T. If it's odd, then how do I make a new odd subset? By adding an odd number, well, I have to add it to an even number. Otherwise, if it's even, I need to add it to an odd number in order to get another odd subset. So let's see how we did. What are the even subsets of 3, 4, 5, and 7? That looks even, that looks even, that looks even. I can't think of any that are missing, so maybe we should try something a little longer. And here we see that there are 0 or 2 odd numbers in any one of these, but there's never just one odd number because that would give you an odd subset. We can get all the odd subsets because we defined that too. How do we know the sums are odd? Well, we could just map a procedure over all of them that applies plus to that s and see whether these sums really are odd. Looks all odd to me. Now, the only thing left to do is deal with the fact that I copied and pasted so much code. In fact, this chunk is identical to this chunk, except for this says even and this says odd. I think a higher order function could fix that. We just define some subset helper that uses even in this case, and I think it needs access to s. And here we want to use a version of subset helper that takes odd instead. Now, what is subset helper? Well, it's just this code that we already defined. Subset helper takes in some f and some s and builds a list that contains everything here, except we call f instead of odd, and everything here, except we call f instead of odd. Fix our parentheses and see if we got the same result as we did before. Looks good to me.